There is one factory in America building the only car that can run door-to-door with a Ferrari 296 and costs half the price. That factory moves at 0.033 miles per hour, slower than a garden tortoise, and every single engine inside it was built by one person, by hand, and signed with their name before it ever touched a chassis. That factory sits in Bowling Green, Kentucky, and what happens inside it is one of the most precisely choreographed acts of manufacturing on Earth. Let that number sink in for a moment. 0.033 miles per hour. The main assembly line at the Bowling Green assembly plant moves so slowly you could walk alongside it for 30 minutes and barely cover the length of a football field. Not inefficiency, intentional. Because when you are building a car capable of pulling 1.2 G on a skid pad, reaching 60 miles per hour in 2.6 seconds, and touching 196 miles per hour flat out, you do not rush it. You sequence it. You orchestrate it. Every bolt torqued to spec. Every panel aligned to the millimeter. Every wire routed with purpose. And yet somehow, one of these cars rolls out of that building every 4 minutes during a production shift. Roughly 200 Corvettes per day, across 4 variants: the Stingray, the E-Ray Hybrid, the Z06, and now the ZR1. All on the same line, all built in the same building, all watched over by about 1,100 workers and 48 robots on the main floor alone. The full story runs deeper than the how it's made surface version. Real engineering decisions, surprising bottlenecks, the near disasters, and the one thing GM actually manufactures at this plant versus everything they receive from somewhere else. By the end of this, you will understand why the C8 Z06 is not just a fast car. It is a manufacturing statement. Start at the beginning, not with the Corvette you know today, with the building it was born in, Bowling Green, Kentucky. Population around 75,000. Known for bourbon, Western Kentucky University, and one other thing most of the country never thinks about. On June 1st, 1981, General Motors opened an assembly plant in the city, and they did it in a building that had nothing to do with cars. The structure was originally a Chrysler air conditioning factory. GM took it over, gutted it, and retooled it for one specific purpose: building Corvettes. Nothing else. Not pickups, not sedans, not crossovers, just Corvettes, every single day, for over 40 years. Today, the plant covers 212 acres. The building itself is 1.7 million square feet. That is roughly 30 football fields under one roof. And within that 1.7 million square feet, the most imposing single section is the paint department. 800,000 square feet spread across 3 full floors, staffed by 240 workers and monitored by 51 robots. Just the paint shop. Just that one department. The Corvette has been built here through every generation since the C4. C4, C5, C6, C7, and now the C8. As of 2023, this facility has produced more than 1.1 million Corvettes. Every single one of them came out of Bowling Green. No other plant in the world has ever built a C8. The only place on Earth. Now here is something that surprises almost everyone when they first hear it. Of all the parts that go into a Corvette, the panels, the glass, the suspension, the electronics, the seats, the carbon fiber, the engine, only one component is actually manufactured at the Bowling Green plant itself. Everything else arrives from external suppliers, already made, already tested, ready to be installed. The one thing GM makes on site is the aluminum space frame, the structural skeleton of the car, the tub, the bones, the piece nobody ever sees once the body panels go on. Think about what that means. The most visible thing about your car, the paint, the panels, the wheels, the interior, came from somewhere else entirely. Bowling Green's job is assembly. The art of taking thousands of individual parts arriving from dozens of different suppliers and turning them into one coherent, high-performance machine in about 36 hours. The aluminum space frame is where everything starts. The C8 Corvette moved to a mid-engine layout for the first time in the nameplate's history, which fundamentally changed the structure of the car. The engine now sits behind the driver, between the cabin and the rear axle. Repositioning that mass changes the geometry of the chassis. The frame had to be completely redesigned. The result is an extruded and cast aluminum structure that is both lighter and stiffer than the C7 steel frame. Stiffer means the suspension can do its job more accurately. Stiffer means the body panels flex less at high speed. Stiffer means a more precise car, full stop. Workers at the plant assemble the space frame using a combination of structural bonding and riveting, a technique borrowed from aerospace. The aluminum sections are bonded with a structural adhesive, then reinforced with self-piercing rivets that are driven through both layers of metal simultaneously, without pre-drilling. No heat, no warping, consistent joint strength across every single connection point. Once the space frame is complete, it moves to the body shop. The body panels are composite fiberglass, not stamped steel like you would find on a pickup truck or a family sedan. The front and rear fascias are formed from urethane, which absorbs minor impacts without permanent deformation. The hood, the fenders, the doors, the rocker panels, all composite, lighter than steel, corrosion-proof, and capable of being painted to the same mirror-like finish as any other luxury vehicle. Each panel arrives at the plant pre-formed from supplier facilities. Workers at the body shop fit those panels to the space frame with extraordinary precision. Gaps between panels on a production Corvette are held to tolerances tighter than 3 millimeters. For a mass-production sports car, that is remarkable. The alignment work is done manually and then verified with laser measurement systems that map every gap in surface in 3 dimensions and flag any deviation from specification. Now the body frame, panels, all pre-fit, moves into what is arguably the most complex section of the entire plant. The paint department. Those 800,000 square feet, 3 floors, 51 robots, 240 workers. The body spends 10 hours traveling through approximately 2 miles of conveyor track inside that department. 10 hours, 2 miles. For paint, 3 coats. First, primer, a corrosion-resistant layer that bonds chemically to the composite and aluminum surfaces, giving the color coat something to adhere to. Robots apply it in a precisely controlled environment where temperature, humidity, and airflow are all managed to prevent contamination. Then the color coat. On a Z06 in rapid blue or carbon flash, the color coat is where the visual identity of the car gets locked in. Robots apply it in thin, even passes, building depth and consistency that would be impossible to achieve by hand at volume. Then the clear coat, the layer that protects the color and gives a Corvette that glassy depth of shine. Between each coat, the body moves through a curing oven. 3 coats, 3 cure cycles, 10 hours total. 2 miles of movement inside one building. One number that never gets mentioned when people talk about car manufacturing, a Corvette's paint job has to survive 150 degrees Fahrenheit in a sun-baked Arizona summer, and minus 30 degrees Fahrenheit in a Minnesota January. It has to grip, flex, stay bonded, and keep its gloss across decades of use. The chemistry involved in making that happen at scale is genuinely extraordinary. After paint, the body moves down to the main assembly line. And here is where the 0.033 miles per hour comes back into the picture. The main line at Bowling Green moves continuously. Not in stops and starts, it moves at a constant speed, all day, every shift. Workers walk alongside the car, moving with it, completing their specific task, then stepping back and letting the line carry the car forward to the next station. At 174 feet per hour, a worker has a specific window of time, measured not in minutes, but in the distance the line travels while they work. Miss your window and the car moves out of reach. Do your job and the next station picks up exactly where you left off. There are 48 robots assisting on the main assembly floor. Some install glass, some apply sealants, some torque fasteners. But the majority of the actual assembly, wiring, trim installation, interior work is done by human hands. Robots handle tasks that require exact, repeatable force application or tasks in confined spaces where human ergonomics makes sustained work difficult. The humans handle everything that requires judgment, feel, and adaptability. Meanwhile, something critical is happening in a separate building inside the same 212-acre campus. The Performance Build Center. The PBC is where the LT6 engine, the heart of the Z06, gets built entirely by hand. One set of hands, one master builder, one engine, start to finish. The LT6 is a 5.5-liter naturally aspirated V8. No turbochargers, no supercharger, no forced induction of any kind, just displacement, precision engineering, and the physics of a flat plane crankshaft spinning to 8,600 RPM. The engine produces 670 horsepower at 8,400 RPM and 460 pound-feet of torque at 6,300 RPM. Those numbers alone are extraordinary for a naturally aspirated engine. But the headline is this: it is the most powerful naturally aspirated production V8 ever built in the history of the automobile. Now here is the detail that changes how you hear this engine. That flat plane crankshaft, most American V8s use a cross-plane crank. The firing intervals are 90 degrees apart, which creates the iconic burbling American V8 sound. Ferrari has used flat plane cranks in their V8s for decades. With a flat plane crank, the firing intervals are 180 degrees apart. The result is an exhaust note that is sharper, higher, more mechanical, like a high-revving European sports car. When you hear a Z06 at 8,000 RPM, it sounds like a Ferrari. Not an accident. Physics. And here is a fact that almost nobody covers. The LT6 is GM's first flat plane crank V8 in 113 years of the company's history. Their first, ever. To put that in perspective, GM was founded in 1908. They have been building V8 engines for over a century. One continuous enough baby in 1908. They have been building V8 engines for over a century. And this is the first flat plane crank they have ever put into a production car. Building one of these engines takes a master builder approximately 3.5 hours, start to finish. Every component arrives at their station in a pre-stage kit. The block, the heads, the crank, the rods, the pistons, the valvetrain, the ancillaries. The builder assembles it by hand, working through a precise sequence, torquing every fastener to exact specification. Setting clearances, checking valve timing. Every step is logged. Nothing left to guesswork. Around 70 master builders work at the PBC. Together they produce around 90 engines per day. Not just LT6S, but also the LT2 for the Stingray and the more powerful LT7 that goes into the ZR1. Each engine coming off a builder's station gets a plaque installed in the engine bay, engraved with that builder's signature. Buy a Z06 and pop the hood. You will see a name, a specific person, their work. After assembly, every single engine is dyno tested. Not sampled, not spot checked. Every one. The dyno run lasts 20 minutes at full load, running through a sequence that pushes the engine to maximum RPM and full power output repeatedly. Any engine that does not hit its specification numbers goes back to the bench. None of them leave the PBC until they have proven themselves on the dyno. The PBC was originally located in Michigan. In 2013, GM made the decision to relocate it to Bowling Green, physically moving the entire operation from one state to another, to put engine production alongside final vehicle assembly. The rationale was sequencing. Because the engine that goes into your specific Z06 is not just any LT6, it is a specific engine, matched to your specific chassis, tracked through the production order system from the moment your car entered the line. Your chassis number and your engine serial number are a pair. They stay a pair. And that is where something genuinely unusual happens in the marriage process. On a traditional front-engine car, the engine drops down into the engine bay from above during assembly. The body rolls over the drivetrain on the line. Standard practice, the C8's mid-engine layout breaks that convention entirely. Because the engine sits behind the seats, inside a structural bay surrounded by the rear suspension, the exhaust system, and the rear bodywork, dropping it in from above after the car is fully assembled is not possible. The LT6 goes in from below. After the interior is fitted, after the glass is installed, after the front suspension is assembled and torqued, the car is lifted. The engine and transmission, pre-assembled as a unit, are raised up into the chassis from underneath on a guided fixture that aligns the mounts precisely. Workers secure the engine mounts, connect the cooling lines, the fuel lines, the electrical harness. The engine is inside the car. The car is complete, structurally. That moment, when the engine is mated to the chassis, is called the marriage. And in the context of the Corvette, it is almost ceremonial. The specific signed engine that was built by one person, dyno tested at full load, and held in sequence for this car's chassis number, locks into place inside the body that was painted, paneled, and trimmed for it. They become one object. Now the drivetrain is in. Next comes one of the most labor-intensive parts of building a Z06 specifically, and the single biggest production bottleneck for this model: carbon fiber. The Z06 is available with extensive carbon fiber exterior packages, the Carbon Aero package, the Z07 package, the visible carbon fiber roof panel, the front splitter, the rear wing, the side skirts. Buyers can spec a car extensively wrapped in exposed, woven carbon fiber visible through the clear coat, showing the raw weave pattern underneath. It looks spectacular. It is also extraordinarily time-consuming to install correctly. Unlike the composite body panels, carbon fiber exterior components require precise alignment, controlled handling to avoid scratching the visible weave, and careful bonding procedures. As of 2026, GM continues to face ordering constraints specifically on the visible carbon fiber packages. Demand outstrips the ability to install them at the pace the rest of the production line moves. Carbon fiber packages remain a hand labor bottleneck. Order a Z06 with full Carbon Aero and wonder why delivery windows are longer than for a base car. That is why. Once the carbon fiber and exterior trim are complete, the car moves through interior final fit. Seats are installed. The center console receives the electronics pack. The instrument panel, with the 12-inch diagonal driver display and the 14-inch infotainment screen, powers up for the first diagnostic run. The steering wheel goes on, floor mats laid in, every interior surface verified against a quality template. Then glass. The windshield is installed by one of those 48 robots on the line. A robotic arm applies a bead of urethane adhesive around the opening, picks the windshield from a rack, positions it, and seats it with precise controlled pressure. No human hand is strong enough or steady enough to apply the same consistent pressure across the entire glass perimeter every single time. The robot does it the same way. Every car, shift after shift. Wheels and tires go on. Fluids, coolant, brake fluid, differential fluid, transmission fluid are filled using automated systems that measure volume to the ounce. The car is started for the first time. Electronics are calibrated. Wheel alignment is set on a four-wheel alignment rack to the factory specification for the specific build configuration. Standard Stingray, Z package with magnetic ride suspension, Z07 track package. Each variant has different alignment targets. Then every car gets driven, not on a public road, on a test track integrated into the plant campus. Drivers run each car through a circuit that tests acceleration, braking, steering feel, and suspension compliance. They are listening for rattles, checking for poles, confirming that the digital systems respond correctly and the analog components, brake pedal feel, clutch engagement point, steering weight, match specification. Any fault found on the test track goes back to the line for correction before the car can pass final inspection. The quality control station at the end of the line is the last gate. Every panel gap is measured again. The paint surface is examined under specialized lighting that reveals defects invisible under normal conditions. Orange peel texture, micro scratches, dust inclusions in the clear coat. The interior is inspected for fit and finish. Electronics are run through a full diagnostic cycle one final time. Every fluid level confirmed. Pass, or sent back for correction. Roughly 200 cars clear that gate every single day. Now here is where the story of this factory takes a turn most people have never heard properly. December 11th, 2021. A Saturday. A line of severe storms moved across the central United States. At approximately 9:30 in the evening, an EF3 tornado touched down near Bowling Green, Kentucky. Wind speeds estimated at 160 miles per hour. The tornado tracked directly toward the Bowling Green assembly plant. The plant took a hit. Fire broke out in the building following the strike. And out in the parking lot, 115 completed, finished, ready-to-ship Corvettes were parked. The cars that had cleared quality control. The cars waiting for transport. All 115 of them were destroyed. Not damaged. Destroyed. GM made the decision to scrap every single one. No vehicle that had been through a weather event of that severity could be certified as structurally sound, regardless of visible damage. All written off. No workers were injured. The plant halted production for approximately 1 week while emergency repairs were made to the building. And then, quietly, without ceremony, it resumed. 200 cars a day. Back to 0.033 miles per hour. The line never forgets what it's doing. Because this plant sits in Bowling Green, there is one final chapter to every car's story that exists nowhere else in American automotive manufacturing. Directly across the street from the Bowling Green assembly plant, separated by nothing more than a 2-lane road, sits the National Corvette Museum. It opened in 1994 on land donated by General Motors specifically so that the car and the factory that builds it would always be neighbors. The museum holds hundreds of Corvettes spanning every generation, racing history, prototype vehicles, and one exhibit that is impossible to forget. A section of the museum floor collapsed into a sinkhole in February 2014, swallowing 8 Corvettes. Several have been restored and put on permanent display, sinkhole damage and all. But the connection between the plant and the museum goes beyond geography. There is a program called the R8C Museum Delivery. A buyer who opts in gets an experience no other American sports car can offer. When your car clears the final quality gate at the plant, instead of being loaded onto a transport truck and shipped to a dealership, it is driven by a plant employee across that 2-lane street and into the museum delivery bay. You, as the buyer, are waiting inside the museum. Your car arrives. A ceremony happens. You take delivery in the middle of a Corvette museum, surrounded by the history of every car yours is a descendant of. You drive it out of the museum and onto the open road. Over 20,000 Corvettes have been delivered this way. 20,000 buyers who picked up their car not at a dealership, but at a museum, across the street from the factory that built it. Nothing else like it in the country. And starting in 2013, GM added one more layer to this experience. The engine build experience. For a fee, a buyer can travel to Bowling Green before their car goes into production, put on a shop uniform, and physically build the engine that will go into their car. Under the supervision of a master builder from the PBC, they assemble their own LT6 or LT2 depending on the variant from the components up. They install the crank. They torque the head bolts. They button up the motor. Their engine then goes through the standard dyno test, receives the plaque with their own name on it, and is staged to be mated to their specific chassis when it enters the line. So I have a question for you, and I want to know your actual answer. If you ordered a Z06 and GM offered you the engine build experience, the chance to fly to Bowling Green, put on the shop uniform, and spend a day building the engine that goes into your own car, would you do it? Drop your answer in the comments. Genuinely curious whether that kind of experience changes how you feel about the car, or whether you would rather just pick it up at the museum and drive it home. If this video earned it, hit the like button and pass it along to somebody who thinks they know everything about American sports cars. Make sure you are subscribed, because the next one goes in a completely different direction, and it involves a manufacturing process so precise that the tolerances are measured in millionths of an inch. When the next car rolls off that line in Bowling Green today, it will take 4 minutes to do so. The one after that, 4 minutes later. The signed engine inside it was dyno tested at 8,400 RPM before it ever saw the chassis. And the person who built it is already halfway through the next one. That is what 44 years of making one car looks like.